Alright, so now we are going to set up the rate law and be able to solve for everything in the rate law equation. It's a little bit mathematical, so you might have to watch this 2 or 3 times to get everything, but let's go through it here. Stay with your book. I'm going to go directly from your book here so that you can look at the graphs and everything that it has listed here. The equation that they're giving us is N2O5 dinitrogen pentoxide goes to 4-nitrogen dioxide and oxygen gas. Now this one is really, really nice because as a gas this is going to leave the system. It is impossible for this to go backwards. So we don't have to worry about a reverse reaction here at all. What we are going to do, since we don't have to worry about the reverse reaction, we're not going to worry about these at all. Okay, we're just going to look at this. And so we're going to set up our rate expression. The rate is going to be equal to negative K negative concentration of N2O5 over the change in time. Change in that concentration over the change in time, which is going to also be equal to K N2O5. Used to writing it the other way now. All right, so these are the 3 things that we've looked at. We've talked about the rate. That's what we're learning about today. How fast or how slow is the reaction going? This is how we're going to do the differential, to look at it with the differential, and this is the form that it's going to give us. All right, so if we take, they gave us this information. Again, you cannot get this from just looking at it. You have to have a table. But they gave us the chart and some information here. And when the concentration is 90 molar versus when it is 45 molar, we see that the rate is 5.4 times 10 to the 4th and 2.7 times 10 to the 4th, negative 4. All right, and remember the rate does change as the concentration changes. That's okay. To figure out the overall order, we're going to take the rate. When we look at it, we can look here and say, okay, if I divide everything here, if I go divide, then I'm going to get 2 is equal to 2. All right, so 0.90 divided by 0.45 is equal to 2. 0.54 or 5.4 times 10 to the negative 4, 2.7 is 2. If that is the case, then we know, oops, I forgot to write this here. This should be an M or an N, either one. It's a variable. Then 1, right, because 2 equals 2, 1 equals 1 basically, is what that number should be. All right, so then we can go in and we can plug everything in for these, and we can say that my rate is 5.4. I'm just going to pick the top one there, times 10 to the negative 4 is equal to K. My concentration at that time is 0.90 molar, and my rate is 1. So now I can solve for this K experimentally. All right, so this is a first order reaction. We can solve for the K. If we go to something that has more than one product, okay, so if I have NH4 plus aqueous plus NO2 minus aqueous goes to N2 gas, and again this is a gas so it's going to go away, so we know that there isn't a reverse reaction to this, plus 2H2O liquid. Alright, so because there's not a reverse reaction we can just get rid of this, but we have both of these things now. So my rate is going to get slightly more complicated. It's going to go rate is equal to my constant, the concentration of ammonium, and N, okay, times its order, and the concentration of nitrogen dioxide and its order. All right, both of those are going to be influential. If I run out of one, then the other one can't go anymore, right? So both of them, we have to figure out what the rate for both of those is. Both of those are. So we're going to set it up just the way that we did before. We're going to look exclusively at NH4 first. Okay, the concentration of NH4. So we've got to pick one where the two concentrations change. So we go 0.100. We're going to go with experiments 2 and 3 over 0.200. Okay, and so then my rates are going to be 2.70 times 10 to the negative 7 and 5.40 times 10 to the negative 7. Well, this is going to be 0.5. This is going to be 0.5. So it's a first order reaction. So my N, this right here, is going to equal 1. Okay, well then I've got to look at my NO2. So let's do two other experiments where that one changes. So experiment number 1 and experiment number 2. So I'm going to go 0.005 molar in my first experiment, 0.010 molar in my second experiment, 1.35 times 10 to the negative 7 is my rate for that experiment. 2.70 times 10 to the negative 7 is my rate for the second experiment. This is again 0.5, this is 0.5. So my rate, or my order for my NO2 minus is also first order. All right. Now the book has it the other way, and that gives it a 2 and a 2 instead of a 0.5 and a 0.5. How you set it up doesn't matter, but you do have to make sure that the bottom is experiment number 2, the top is experiment number 1, or the top is experiment number 2 and the bottom. You can't have this be 0.010 and this up here be that's going to screw you up. So make sure that if this is your second experiment, all your second experiment information goes there, and then you're fine after that. So then so my rate was NH4 plus N, NO2 minus M. We experimentally determined, and I forgot my K in there, that NH4 plus had a 1 and NO2 minus had a 1 as well. So we can change it to that. Now we can go back and pick any one of those experiments, plug in all of our numbers, and we would see it. So let's do experiment number 3, 5.40 times 10 to the negative 7 is equal to K. My concentration of ammonium at that point in time is 0.200. My concentration of nitrogen dioxide at that point in time is 0.10. And I could solve for this K now. And that would be 2.7 times 10 to the negative 4. Liters over moles seconds. All right. So make sure you do the sample exercise there. That's got 3. It's going to be the exact same thing. Remember, we're just going to take all of our products and we're going to put them all in. So I'll set this up, the form of it up for you really quick here. BR, and the book also does this. But I wanted to bring up one thing really quick so that it didn't confuse anybody. BR, these are all of our products. H plus, these are all of our reactants. They changed this to P just because if they went M and O, it would look a lot like a 0, and it's not a 0. You can have a 0 order reaction, so that's why that's a P and not an O or anything else. But really and truly, any letter that you want to pick to put there, if you want to pick A, B, C, or X, Y, Z, feel free to change that. All right.